Hello class, welcome to our first piece of the Chapter 3 review. We're going to go through some different topics. I'll spend some time looking at especially percentiles today and a few other pieces just to make sure we're all on the same page when it comes to Chapter 3 material. First thing that you would like to, you want to make sure you know is how to deal with measures of center, so things like mean, median, mode, mid-range, measures of variation like standard deviation and variance. And then the symbols that are used, so like X bar, for example, is mean of a sample and those types of situations. You want to make sure that you're able to find those and use those as you go through each example question and know what each of those symbols represent. Below is a list of some different weights of books. I went ahead and ordered them for you, and then I just found a bunch of information. So you need to look at this list and make sure you know how to find the mean, the median, the mode, the mid-range, and the range. All of that group should be able to be found by hand on a test situation. I'll probably give you a small enough data set that you'll be able to find those fairly quickly. Common mistakes I've noticed is the mode has more than one because there's multiple numbers that appear twice. The standard deviation and variance would be given to you, okay, in some way. Either use StatCrunch on your homework, or I will give that information to you on a testing situation, just with the way everything's set up right now. So just keep those things in mind, and then the variance is the standard deviation squared. The 5-number sum, remember, is the lowest number, first quartile, median, third quartile, highest number. You should be able to find that either way. By hand, you would find the median first, and then look at the median of the upper and lower half of the data, and those would represent your Q1, Q3. You can also use StatCrunch on your homework, and that'll give you the 5-number summary, so you can use that to help find what you need as well. In terms of outliers, what you need to know graphically is that a modified box plot could be used to figure out if something is or is not an outlier. Algebraically, what we would use is Q1 minus 1.5 of the IQR, or Q3 plus 1.5 of the IQR. And you would use that to help find your answer to figure out if something would be an unusual data point or not. The last thing on this slide is dealing with a z-score. Remember, to find a z-score, you take your data point minus the mean, then divide by the standard deviation. In this case, 5.2 pounds minus the mean of 31 pounds divided by 3.41 is the standard deviation. You get 0.26. That would not be considered to be an unusual data point because it's within 2 standard deviations of the mean. Okay, percentiles. This is looking at 11 test scores for a class. So n is 11. I'm looking for the percentile that corresponds to a score of 37. So here's 37 right here. Okay, 37 is the 4th data point in. And so there are 3 numbers less than 37. And so that would be 3 over 11 because there's 3 out of the 11 numbers are less than 37. Times 100 to make it a percent. I get 27.2, round to the nearest percent, and I get P27. Same thing for 75. 75 is the 9th number in the list, so there's 8 numbers below it. So there's 8 out of 11 times 100. That would give me 72.72, and then that number could be rounded to the nearest whole number, which would be the 73rd percentile for the number of 75. When you work backwards, you have to take the percentile divided by 100, which essentially just makes it a decimal, times the number of data points. So 24 out of 100 times 11 would be 2.64. I always round up when working backwards. Your book uses the letter L to represent for the location, but it's the 3rd number. Remember, it's not 3, it's the 3rd number, and that would represent 30 then, because P24 would represent the 3rd number in the list, which is the number 30. The next one is the 78th percentile. To figure out the 78th percentile, I'm going to take 78 divided by 100, which will give me 0.878 times 11, which will be 8.58. Now again, this rounds up to 9, but we should round to the nearest whole number no matter what in this situation, and that would give me the 9th number in the data set. And when it's the 9th number in the data set, I'm looking for that spot, and that would be 75 here. So the 78th percentile represents the number 75. The next thing to discuss is just dealing with bell-shaped curves. So remember, in a bell-shaped curve, 68% of the data is within 1 standard deviation, 95% within 2 standard deviations, and then 99.7% within 3 standard deviations. If it's not a bell-shaped curve, you have to use the Chebyshev's theorem, which is 1 minus 1 over k squared. If k is 2, it's going to be 75% because it's going to be 1 minus a fourth. If there's 3 standard deviations, it ends up being 88.9 because it's 1 minus 1/9. So those pieces are things that you want to look at when it comes to bell-shaped curve versus a non-bell-shaped curve. Just a review of z-scores. This says a commercial break during a game has a mean of 250 or 245.2 and a standard deviation of 36.4. If we're looking for a commercial break of 188, we would say, is this unusual? It's not good enough just to say, oh yeah, it's got a big difference between that and the mean. We have to find the z-score. So take your data point, 188, minus the 245.2, find that answer, and divide by 36.4. We're always going to round z-scores to the nearest hundredth, and so that gives me negative 1.57. That's not unusual. Even though it's very low, it's not unusual because it's not 2 standard deviations away. The next question talks about SAT and ACT scores. Now this is based kind of on the old format with the essay piece, which isn't as normal now for the SAT. But the average before, when the formatting included the essay, is 1516 with a standard deviation of 315. So on the score of it on the SAT, I got 1040 minus the mean divided by the standard deviation. What this tells me is I'm 1.51 standard deviations below average. Okay, so whatever number I got, it's irrelevant how far apart that number is, it's how many standard deviations away you are. So in this case, I'm 1.51 standard deviations below average because my z-score is negative. If I do the same thing on the ACT, I have 13.9 minus 21.3 for the mean. Divided by 5.2, I get negative 1.42 standard deviations below average. Now, if you look at these two numbers, they're not very comparable because their scales are different. But when we convert them to z-scores, this ACT score is better because I have a higher z-score value. Even though it's still below average, I'm closer to the average here than I was on the SAT. So when you're looking at these ideas, it's probably find the z-score and compare them. If you're only looking at variation, it's probably find the coefficient of variation, which would be the standard deviation divided by the mean, and that would tell you which one varies more. But if you're just looking to see which one you did better in, you can find the z-score and then compare them. Okay, that's everything for this chapter review today. We're going to go over some more questions dealing with percentiles in the next lesson, and also review some things about coefficient of variation and how to find those answers. Have a good day, everyone.